Hello, welcome to the Unitronics webinar number 4 on data tables and data logging. Today is part 1 of a 2-part webinar series on data logging. This is actually a re-recording of the live webinar. Welcome to the Unitronics webinar number 4. This webinar is on data tables and data logging. This is actually a re-recording of the live webinar we did on Wednesday, the 14th of January 2011. This will be the first part in a 2-part webinar series. Today we'll be going over how to create a data table, how to use the data table tools and functions. We'll be creating a simple data logger which will record the date, the time, a memory bit, a memory integer, and a memory long. We'll also take a look at some interesting system bits that we have available for use, and we'll take a look at creating a timer function so we can create our data logging on any time interval we're interested in. We will be going over in the next webinar how to pull these data tables out of the PLC and save them on the PC as an Excel spreadsheet. But today we'll just stick with our simple demo. For today we'll be using a Vision 570 controller. That's the 5.7-inch color touchscreen. And we'll be using VisiLogic version 9.0.1, which is currently the latest version of our software. So the first thing we need to do when working with data tables is figure out exactly what kind of information we would like to save in them. I'm going to go ahead and click here on the icon for the data tables. Notice we also have a drop down here where we can select the data table, or in the navigator we can select data tables. What we want to bring up is this data table editor. Now again, as I mentioned, the first thing you need to know when working with the data table is what kind of information you're going to read or write to it. This is because we need to define a structure for the data table. If we don't know what the information is that we're going to use, we can't define a structure. So, as I said, we're going to start with the date and the time, and then three registers or 3 variables just as an example. So we're going to build a simple example program, and we're going to look at how it is saving the data. So the first thing I want to do, again, in the data table configuration menu, I'll just go back and show we have this icon here, is create a new table, and I can do that by clicking on the add table icon. I get the option to give the table a name. We're going to leave it as table 1, and to set the number of columns and the number of rows. So in this case, we want to write 5 pieces of information. Again, date, time, a memory bit, memory integer, and a memory long. So we need 5 columns. The number of rows, we're going to use 100. Let's take a look at what happens if I type in 33. Notice that the maximum number of columns we can set is between 1 and 32. So it's just something nice to keep in mind. In this case, again, we're going to go from 5 columns and 100 rows, and we'll hit OK. Notice that under the table section we now have our table 1, and pertaining to table 1 on the right here is the layout of our table. I'm going to go ahead and add just another table here, so we'll have table 2. I'm not going to change anything. I just want to point out that the difference on the right side is the structure of each table. We haven't talked about the structure yet, but it's important to note that each of the table entries we have will be different from each other. I'm going to go ahead and erase that with the delete table button. Okay, make this one a little bigger. Now what we have is our column 0, 1, 2, 3, and 4, and our rows going from 0 to 99. You notice that there is no it starts on 0. There's no row 100. This is just a naming system that is common. We're now going to go ahead and configure the first column. I'll go ahead and double click on column 0 here. Now what we're going to do is change the description from column 0 to date. So we're going to, of course, have the date and the time. These are two separate pieces of information. They're each going to get their own column. Under type is where we can select what type of register we're going to link this column to. We have Boolean, which will be our bit value, byte, integer, which is our 16-bit signed integer. We have unsigned integer, long, double word, timer, float, and string. You notice that these are all the operand types available in our system, as well as the indirect options. So we have address of MI, address of ML, address of SI, SL. What this means is that instead of linking to a specific integer, for example, if we link this column to, if we call it an integer, and we use the write tool to write to memory integer, to read from memory integer 5. If we use an indirect option, we would use memory integer 5 as a pointer in that case. So we can read from any of the memory integers that we have available in our system using the address of MI instead. But in this case, we're going to use a nice function we have called RTC to ASCII. And this is a real-time clock to ASCII tool. In order to use this, we need to set our type as a string, and this is because the RTC to ASCII tool saves strings. We'll take a look at that in a little bit, but we'll take a look at the rest of the options we have available here. Part of project or read-only. If we select either of these, they will not enable us to write to the data table. Part of project is actually another memory location for data tables. We'll take a look at that one in a sec, but the read-only option would disable our ability to write to this column. And of course, we're trying to create a data logger, so we don't want to use that. Now the string length is a piece of information that pertains to the string. We're going to leave it as 10, and we'll talk about strings in a little bit if we're unfamiliar with them, but it's basically the maximum amount of characters that we can write to this column. So we can write anywhere between 0 and 10. I'm going to hit OK here. Notice that our description has changed to date, and instead of seeing integer below, we see string and 10. These are the two pieces of information that pertain to writing a string. I'll now configure column 1, and so we have our data ready. Let's create time. Again, we're going to use a string because, again, we're going to use our RTC to ASCII tool, and we're creating ASCII strings, of course. So I'll hit OK, and notice that we've changed our description to time, string 10. Now for column 2, we're going to call this our data bit. And we're going to change it to a Boolean. Again, a Boolean is where we'll store a memory bit or a system bit, any bit value. Notice that we still have part of project and read-only, and of course we're not going to select these, but in addition we have the number of elements. What this means is, we'll just go ahead and increase it, and we see that we can link either by default 1 or 2 or 3 or 4 or 5 or 6 elements. What this means is, instead of addressing a single memory bit, we will address, in this case, 3. So we'll have a vector of 3. The start of vector will be the address we point to, and we'll read sequentially from there. So if we say, for example, memory bit 3 in this case, we will store memory bit 3, 4, and 5. Or if it's memory bit 10 is the start of vector, we'll store 10, 11, and 12. So the idea of a vector is that you have a start address and you have a length, or in this case a number of elements, and they're always sequential and they always follow. The same thing is true about strings, and we'll discuss those a little bit later, but I'm going to put this back to a single element. We notice that we've changed to data. Oops, we need another A over here. We have data bit. Column 3, we're going to change to data int, and we're going to leave it as an integer. And notice now we have more properties available. We have a min and a max. This is because the data type integer is a 16-bit signed register. What that means is we have a range of 0 to 65,535 as far as values we can store into this integer. If we divide it in half, we get our signed values, so negative 32,768 to 32,767. We can change the format. We can use decimal or hex. In this case, we're going to leave it as decimal. And again, we can change the number of elements, but we're going to leave it as 1. I'm going to hit OK now. And again, I keep doing that. Data int. Okay. Column 4, we're going to change to data long. And instead of integer, we're going to select long. And again, we see reflected the data type long, which is a 32-bit signed register. Negative 2,147,000,000, something, something, to 2,147,000,000. So this is also interesting if we're not familiar with data types. It's very important to know what value we're going to store into what register. If we want to store the number 500,000, we certainly cannot store it into an integer, but there's plenty of space to store this value into a long, as well as a double word, which would be an unsigned long, ranging from 0 to 4,290 something million. Okay, so I'll hit OK here, and notice that our 5th column has changed as well. So now we see reflected our date, time, data bit, data int, and data long. Okay, so again, we need to know the structure that we wish to work with, the data types, and the pieces of information we wish to save to a data table before we can set it up as a data logging function. And I think this makes sense. If we're going to design a machine or a piece of equipment, of course we're going to know that we're going to have some temperature input or some pressure input. Let's take a look at the tools we have available to us. First, of course, is the Save button. We can import and export to a file. So this means we can import and export this specific data table and import it into another PLC's project. This is nice because, as I mentioned, the structure is what defines the data table. We cannot share data from one table to another unless we have either the same structure or some logic set up in our ladder in the PLC to do so. If we wish to maintain the same file type, meaning if we're going to export this to Excel and we have some script or some macro set up to read from 2 columns that are strings and then three more columns that are of a certain type, we want to maintain the same structure. So this is very important. We can as well import the database structure to XML. So if we have some third-party software, that database software, say, that works with XML files, we can support these. We can import and export to Excel, of course. And we'll see next week how to do this with our data export software, and we'll do it automatically on a time basis or event basis. We can also import and export to a CSV, which is a comma-separated variable file. These are natively supported in Excel as well, so sometimes they'll be exchanged as the same name, but they are different. They are different file formats. We can copy and paste, of course. This means cells. So when using these tools, all these tools actually, we can select certain rows, columns, certain cells. We can click on a column to select the entire column, same as a row. And if we click the button row, we select the entire table. So it's very interesting to note. It's very useful. Continue on here. We can read the structure from a PLC. This means that we can